Okay, folks, welcome to our problem solving related to maximizing area with a fixed perimeter. This problem hopefully will be a little less enjoyable than the one we worked on in class today. So let's take a look at this. Very similar problem that we did earlier, but I'm hoping a little less complex, just kind of nasty numbers with decimals. So we've got 10 centimeters of rope to make a very tiny square and a tiny circle, and we want to make the most possible area with that rope. So given that we have a square and a circle, we're going to label some dimensions. The first instincts probably would be go to x, x, and x for that length, and then for the radius of the circle we might call it y, in which case we would have a formula of perimeter equals 4x plus 2 pi times y, because y would be the radius. But we also know that that happens to be worth, the perimeter happens to be worth 10. We also know that the area of these shapes then will be x squared plus, what would that be, pi y squared. So when I take a look at that, let's see. I know that this is the formula right here that I'm going to have to eventually get negative b over 2a for, because I want to make a maximum amount of area. So I know I'm going to have to work with that formula. But I've got a problem in that in this case I have x and y and a. I can't have three variables. The most that I can work with is 2. So that means I'm going to have to get rid of either y or x, and most commonly we eliminate y. So let's take a look at the equation before, which is this equation here. We know it's worth 10, the perimeter is worth 10. So I either have to get y by itself or x by itself. Well, if I look at this equation here, for x, it's a lot easier to get x by itself than it is to get y, because to get y by itself I'm going to have to divide by 2 pi. And if I'm going to divide to get x by itself, I'll have to divide by 4. So it'd be easier to get x than y. So, but I typically don't like to do that. So what I'm going to do is go back actually, and I'm going to erase this right here. Oh, actually I can't erase. That's interesting. Okay, well I'll write over top. That's not a problem. So instead of x, I'm going to make that y, 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 and I'll make that radius x. So that will no longer be the equation. The equation will now be 4y plus 2 pi x equals 10. So I need to isolate for y in that equation and substitute it into the area equation. So in order to do that, I'm going to have to subtract 2 pi x. So 4y will equal 10 minus 2 pi x. And divide both sides by 4. And y will equal 10 divided by 4 minus 2 pi x over 4. And then what I'm going to do there after that is to actually isolate, or not to isolate, but simplify that. So y will equal 2.5 minus 1.57x. Okay, let's think about that for a second. Where does that 1.57x come from? 2 times 3.14 divided by 4. Okay, so there's my equation for y. This y can now be brought up and be placed right there. Oh, except that, whoops, I need to rewrite this equation because this equation is now wrong. I need to write it as a equals y squared plus pi x squared. So that means that what I'm going to have to do is take this equation and substitute it in for y. And that's better anyway, because I wouldn't want to have to multiply by pi, right? So I'm going to replace the 2.5 minus 1.57x, I'm going to substitute that in for y. So I'll write it in a different color now. 2.5 minus 1.57x squared plus pi x squared. And now I need to expand that out. So I'm expanding the expansion of this 2.5 minus 1.57x all squared is not a nice expansion, but I will write it out here. The expansion to that is 6.25 plus 2.47x squared minus 7.85x plus, then I've got this pi squared. I'm going to make that, ooh, this is not very nice. Sorry, folks. Plus 3. You know what? Let's just go to the next page. My apologies. My apologies. See if that'll work now. Yeah, now it'll work. Okay, so I'm just going to erase that and bring this onto the next page. It's nice to work with a clean page. So I'll rewrite that. So I will rewrite that. So in this case, area equals 2.5 minus 1.57 squared with my x plus pi x squared. So when I square that, I square the 2.5, 6.25. And then what I do is I multiply, since it's a square, let's go through this. So 2.5, I square that to get 6.25, and then I have 2.5 times negative 1.57 times by 2. That's how I get the middle term. So that's going to be minus 7.85x, and then I square the last term, 1.57x, and that becomes plus 2.47x squared plus this part right here, which I'm going to simplify as 3.14x squared. After this, I collect like terms, and I'll put that under blue here too. So I had 2.47x squared plus 3.14x squared, and that will simplify to 5.61x squared minus 7.85x plus 6.25. So hopefully, folks, that what you do, remember to pause it at any point in time and go back and replay it to make sure you understand it. So that's our area formula. It's a quadratic area formula, and it opens up in this case. So we're going to get, actually I guess we're going to get a minimum area here, not a maximum area, because it's 5.61x squared. I hadn't thought about that. It's interesting. So let's do x value of the vertex is negative b all over 2a, which will be negative b in this case will be the negative of 7.85, which is 7.85, all over 2 times 5.61, and that will equal, come up to here, x value of the vertex is 0.70 centimeters. So if we look at that, in that case we now have, in this case here we have x as our circle. So the area of the circle with the radius of 0.7 is pi times 0.7 squared. So we have 3.1416, etc. But I could just put the pi symbol in, times 0.7 squared, which is 0.49. Works out to 1.5 0.54. So the area is 1.54 on the circle. And that means there is, so we've got that area. The other thing I need to do now is look at how much circumference that takes up. So the area part I could have done later actually. So the circumference on the circle is equal to 2 times pi times 0.7. The circumference on the circle will equal 4.4 4.40 centimeters. And I'll just go to the next page. So we had the square plus the circle, which is 4.40, and the total is 10. So that means how much is left over for right here? Well, it should be 10 minus 4.40, which equals 5.60 centimeters, and that needs to be divided 4 ways because there's 4 sides to that square. This works out to 1.4 centimeters per side. Okay, so therefore we have a square that is 1.4 by 1.4 centimeters, and we have a circle that is of radius, or has radius, r equals 0.7 centimeters. A nice easy problem, right? And I know these are challenging. These are very challenging problems. But what I think you probably should do is perhaps go over it once again. And what I would like you to do now is to do the exact same problem, except set the perimeter equal to 20, which will change all your numbers. But then, of course, the ratio should stay the same. So you'll get, as long as your radius remains, it should be in the same proportion, right? So you should get double the radius of 1.4, and you should get double the side length to 2.8, and in that case you will have done perfectly. Okay, so do it with perimeter equals 20, same problem, and work through it. Good luck, and I will see you on Monday.